Hello everyone, in today's video I'm going to present the forest plot and I hope that I can make you have a clear understanding about it. Here we come to our final forest plot where we have the true effect, where we have all the studies together and we have the pooled effect from our studies. Let's try to understand this. First of all, we have to look at the picture. We have to see that we have vertical lines, horizontal lines, we have rhombs, we have points, we have different datas. So let's try to identify everything on our forest plot. Let's try to define everything and then let's try to understand how to read it. We have the vertical line. This is the line of no effect. This is the line of null hypothesis. If we have to have like a brain map, we can first identify the vertical line. Then we can identify the diamond at the bottom, okay? This is the diamond at the bottom. This is the pooled effect side. After we have the pooled effect side, we have to check for the p-value. If the p-value is less than 0.05, we reject the null hypothesis, which is no effect. The one is null hypothesis. But if the p-value is more than 0.05, we accept the null hypothesis and we will say that there is no true effect in our study. So actually our final results assume that we have a true effect. Then we have to examine the blue squares. The blue squares and the confidence interval. Evaluate the square size and determine the statistical weight, which means this square has a bigger weight in our study than this square because they are more powerful. Maybe they have a better sample size or they have a good powerful protocol. Their study is more powerful and more relevant, and that study weight the true effect to its own effect. And then determine line of no effect. Does the confidence interval cross the line? If yes, results is inconclusive. If no, results are significant. So this A, significant, this B, non-significant, this C, significant. And now we have to understand how to read the p-value, because this is sometimes misunderstanding because it used to be like an important value in the previous papers, but nowadays we understand that the p-value is not the ultimate goal we have to achieve in our paper. The p-value actually check for type 1 error. A type 1 error is when we might find a true effect where there is none. If the p-value is extremely low, like in this situation, we reject the null hypothesis. If the p-value is more, we accept the null hypothesis. The p-value doesn't show the clinical importance, doesn't show the effect size, doesn't confirm the truth. And it's an arbitrary threshold. Even if we assume that 0.05 is our threshold, it's still an arbitrary threshold. And is misleading in small studies. So we have to step forward to see if our results is reliable. And to do that, we have to do sensitivity analysis, publication bias assessment, or grade approach and grade approach. And here are the steps. Once again, we collect the data, we standardize the inputs, we do the preliminary plot, we test for heterogeneity, we do the model section, we have the final plot. After the forest plot, we have to interpret results, and this is how we draw conclusion. This is also so important. The forest plot is not the final goal. The interpretation of the results and the clinical importance of our results is the final step. So thank you for staying with me until the end.